Okay, so we're going to do some free fall problems. Problem 59 says that a student drops a ball from the top of a building and the ball takes 2.8 seconds to reach the ground. So there's two parts to this question. One is, what is the ball's speed just before it hits the ground, and then what is the height of the building? I like to draw a picture, and so I have the student laying down, and he's going to drop the ball in such a way that it is the exact height of the building. Now the acceleration, we don't know, but that's okay. But the time is 2.8 seconds. So let's go with the ball. 2.8 seconds later, it hits the ground. So we're asked to find the final velocity. And then for part B, we're asked to find the height of the building, which is delta y, sort of. Okay? So let's think about all the things that we know and list them and find an equation. Well, we know that the acceleration due to gravity is 9.8 meters per second. In the negative direction. And so this is, I'm going to explain this as best I can, but your book changes the equations. So normally, if y was 0 meters, in other words, the ground represented 0 meters, and the top of the building represented a positive height. In other words, going down is in the negative direction. Normally, we would say that the acceleration due to gravity would be negative 9.8. Well, when you look in your textbook, it says that the acceleration due to gravity is g, and it says positive 9.8. And what the textbook, what the authors have done is they've changed all of the equations. So any equation that's a kinematic equation for free fall has a negative sign in front of the g term. So this equation normally would be v naught plus a times t, but because we're using g, they put the negative sign. So I'm going to find the final velocity by using this equation by simply plugging in that the initial velocity is 0, the ball wasn't moving when you let go of it, and then I'm going to minus the 9.8 times the 2.8, and I get the final velocity was negative 27.44 meters per second. Now we got to keep in mind that the negative sign just represents the direction. It was moving at 27.44 meters per second, but it was moving in the negative direction. In other words, the ball was going down, right? So it's pretty easy. Well, it's not easy. It's easy for me, but just keep in mind that if you end up with a negative number, the negative sign represents the direction, not so much the value of the number, okay? It's the magnitude of the vector that gives us the value. Another way to think of this is like, think of a thermometer. If I go below 0, I'm going to go down in the negative direction. So I'm going down means negative. If I'm to go up, then that's the positive direction. Our velocity was 27 meters per second. However, it was going in the negative direction. So the equations are written in such a way that if you get a negative answer, you know which direction you're heading. If you get a positive direction, you know which way you're heading. And then the scalar or magnitude of the vector is based upon the number itself. So negative 27.44 meters per second means that we went down at a velocity of 27.44 meters per second. So that's part A. Whew, that was a lot of talking. For part B, we're asked to find the height of the building, which is delta y. So now that I know the final velocity, I know the initial velocity, I know the acceleration due to gravity, and I know the time, I look at my kinematic equations for free fall and see which one will help me determine that. So if you look, you'll see that there's one equation I can use, delta y, and we want to be careful, but if I say delta y is equal to 1/2 times v plus v naught times t, after I plug in all the numbers, in other words, I've got delta y equals all the numbers. I have everything I need, which is 1/2 times negative 27.44 times 2.8. That gives me a negative 38.416 meters. Now the problem is that the height of the building is 38 meters roughly, but I got a negative number. What that means is that the displacement of the object was in the negative direction. The question for part B actually says, what is the height of the building? The height of the building is 38 meters, or 38.416, but the negative sign represents the direction. Now, I don't know, you can make up a fancy rule, or you could just think about what you're doing. The negative 38 represents the displacement of the ball. How far did it move? 38 meters. What direction? Down. How do I know? Because it's negative. But what's the height of the building? Just 38 meters. So when we use the equation and we calculate and we get a negative answer, we have to think about the problem. It was the ball that was dropped that moved 38 meters, which is the same as the height of the building, but it moved in the negative direction, which is why the equation gave us a negative value. That's pretty much it. Are there any questions?